Hey everyone, welcome to this explainer. Today, we're cracking open a really fascinating guide from InfoGuide NG, and it's all about an absolute game changer for off-grid living, the AC to DC refrigerator conversion process. Seriously, if you're looking to make your energy stretch way further, and you've ever wondered how to totally optimize a solar power setup, well, let's look at exactly how to make your appliances work smarter, not harder. Let me ask you this right out of the gate. How on earth do you run a fridge on a solar setup without completely draining your stored power overnight? It's a massive problem for us off-grid enthusiasts. Standard AC appliances hooked up to an inverter, they just suffer from constant conversion losses and parasitic draw. When you hook up a standard household fridge to that battery bank, the inverter basically eats through your solar energy before it even reaches the compressor. But the solution we're unpacking today frames this entirely differently by changing the fundamental nature of the appliance itself. Okay, let's dive into this. Why convert to DC? Let's take a quick look at the massive benefits of doing this swap. So, according to personal experiments detailed by InfoGuide NG, where they actually went ahead and compared AC and DC compressors across different times of the day on different power sources, this conversion method absolutely crushes traditional setups. First off, you get way higher efficiency. By running on DC, you literally eliminate the middleman, the inverter, meaning your compressor utilizing the power directly from your batteries so much more effectively. Second, you achieve a faster cooling rate. Your food gets colder quicker, and that means less prolonged, drawn-out strain on your solar battery bank. And third, it's surprisingly cost-effective, especially if you're trying to run, say, large commercial freezers off a solar grid where literally every single watt counts. Now, speaking of the specific target here, the magic number we're usually talking about is 12. We're looking at converting a standard household freezer to run on 12-volt DC power. Why? Well, mainly because 12 volts perfectly matches standard off-grid battery banks. And here's the reality check, right? Buying a brand new, factory-built, dedicated DC solar freezer can be shockingly expensive. So taking a perfectly good AC freezer you already own and just swapping the internal components to 12-volt DC, it's often highly advisable. It saves you a massive upfront cost while still delivering that sweet, sweet off-grid direct current efficiency. Let's move to and see how this builds. We'll look at the core conversion process and break down the actual mechanical steps. So there are three main steps to getting this right. Step 1, matching. Listen, you can't just grab any DC compressor off the shelf. You absolutely must match the wattage and the liter rating of your specific fridge or freezer so the new compressor can actually handle the volume. If it's too weak, it'll just run continuously and burn out. Step 2 involves welding the suction and discharge pipes, which we'll look at more closely in a second. And step 3, hire a professional technician for the installation. Even though taking out the old compressor is, very simple technical work, the precise matching and physical integration really requires specialized hands-on skills. And this brilliantly illustrates exactly what we mean by those specialized skills. Welding, in this specific context, means physically connecting the corresponding discharge and suction types of your brand new DC compressor to the existing copper infrastructure of your refrigerator. You're basically permanently marrying the new efficient heart of the machine to the old body. It has to be sealed perfectly, without a single micro leak, or the refrigerant just escapes and the whole shebang fails. All right, critical technical precautions. Now, I need to slow down for a second because while removing the old compressor is simple, the electrical phase is where the stakes get incredibly high. Yeah, this is exactly where a fun DIY project can turn into an expensive nightmare really fast. Extreme caution is absolutely crucial when connecting cables to the electronic driver attached to the new compressor. Why? Because if one cable port accidentally touches another while you're wiring it, it's going to spark, and that single spark will fry those delicate electronics instantly. It literally takes a fraction of a second to ruin the entire setup. And the worst part? These specific driver motherboards are notoriously difficult to repair. If you burn it, you're almost certainly buying a whole new one. No way around it. So, the crucial point here is perfectly summarized by this direct quote from the InfoGuide NG article. The conversion process, quote, requires precision and technical expertise, particularly when wiring the electronic driver to avoid damaging the components, end quote. This is exactly why the guide strongly recommends bringing in an experienced technician. Sourcing the parts yourself to save some cash, that's a great strategy. But letting an expert handle that delicate, spark-prone wiring phase, that is for sure the absolute best way to protect your investment. Let's look at simpler alternatives to conversion. Because hey, if welding pipes and managing sensitive electronics sounds way too stressful, there are other options on the table. Now, what's really interesting about this slide is comparing the ease of these alternatives against the DIY method. If you skip the technical route, you essentially have two choices. Option 1, you can simply install a solar inverter to power your existing AC freezer. Now, it's definitely less efficient because of those constant conversion losses we talked about earlier, but it's plug and play, zero physical modification to your appliance. Or option 2, you bite the bullet and buy a completely new dedicated DC solar freezer. Much more expensive up front, sure, but it's guaranteed to work perfectly off-grid right out of the box with absolutely zero labor on your part. It's that classic contrast, right? Ease versus budget. Which brings us to the ultimate question for your off-grid setup. What is your next move going to be driven by? Your technical confidence or your budget? Are you willing to take on the minor risks and hire a technician to reap those massive direct-to-battery efficiency rewards of a DC conversion? Or would you rather play it safe and spend the extra money on an inverter or a brand new factory unit? It's a really fascinating choice to weigh up, but armed with this information, you are now completely ready to plan the most efficient solar setup for your needs. Thanks so much for joining this explainer.